So 34 is a complex fraction. So what we're going to do is we're going to find the common denominator, and we're going to multiply everything by that common denominator. So if you look at the denominators, you have t squared, and t. So those are all the same factor. It's just we're going to use the highest one, which is t squared. So we are going to multiply every one of these by t squared. So we're going to do each piece of this by t squared. And then we're going to reduce. So this t and one of the t's will reduce. T squared and t squared will reduce. T squared and t squared will reduce. One of these t's will. So here we just have 2 times t minus the 3. On bottom we have just the 5 plus the t squared. And these are the same thing. Or plus the t, not the t squared, but they're the same thing. 5 plus or t plus 5 are the same thing. So far, we have looked at rational expressions. So when I add two numbers, I actually have an expression. The difference between a rational expression and a rational equation is that in an equation, you have an equal sign, and you're actually solving for. Expressions, you're just simplifying. You're going to potentially have a variable left in your answer. You're just getting it as simple as possible. But when you have an equation, you're actually solving for something, and so you're looking for a solution. You do have to check and make sure you don't have an extraneous solution, because remember, when you have a rational, that means you have a denominator. And anytime you have a denominator with a variable, there's something you have to be on the lookout for, because we cannot divide by 0. And so anything that will make your denominator 0 could potentially be a problem, all right? And so sometimes you will solve for answers and they don't work because they would make your problem have an excluded value. So at the very bottom of this paragraph, it says you must check for extraneous solutions. That's what you're looking for. Do I have a problem with any of the numbers that I have solved for? All right. And so we're going to actually use the same method that we use with solving the complex fractions. There are actually 2 ways to do this. You can get a common denominator and you could then add them and do it that way. The easiest way is actually to get rid of your denominators altogether. When you get rid of your denominators altogether, then all of a sudden you have something a little bit easier to solve. So to get rid of denominators, and this is true of all fractions, is I am going to multiply everything by my common denominator. So I'm still going to look for my common denominator here, and that's what I'm going to use to solve this. I have to use the x plus 3, and I have to use the x. And so my common denominator ends up just being x plus 3. All right? And so once I have that, I am going to take my equation that they have given me, and I am going to multiply everything in that equation by my common denominator. So we want to first find the common denominator, and then we want to multiply everything by the common denominator. So multiply every single term, every term by your common denominator. So I'm going to take this and I'm going to multiply it by x plus 3. And I'm going to take this and I'm going to multiply it by x plus 3. All right? Now, anytime you have a numerator to a denominator, you can cancel because this is multiplication. So this whole x plus 3 can cancel over here, and I'm left with just the 18 and the x. And over here, my x's can cancel, and I'm left with 12 and x plus 3. This looks way easier to solve, right? I'm going to distribute, move my variables to one side, multiply or divide, right? And so I'm going to distribute this guy right here. I have 18x equals 12x plus 36. I'm going to subtract my 12x. This should be second nature here. So 18x minus 12x gives us 6x equals 36. And then I am going to divide both sides by 6. X equals 6. The only thing I need to do is go back up here and say 6 plus 3 in the denominator. That is 9. That's fine. 6 in the denominator. That is also fine. It does not cause a 0 in my denominator. So this is my answer. X equals 6. You can also check it, by the way. You can plug your 6 back in and see if you get an equivalent statement or a true statement. The very first step remains the same. I need to find my common denominator. All right. The way that I do that is I'm going to factor everything. Well, x minus 4, that is as small as that gets. Here, I can factor x minus 4, x plus 1. And here, x plus 1. All right. So those are my three denominators. I have to use the highest of each term. X minus 4, well, that is only used to the first power. So x minus 4 is going to be part of my denominator. X plus 1, those are both only to the first power. So x plus 1 is part of my common denominator. So this is my common denominator right there. And now I'm going to take each piece. Since I've already factored the denominators, I'm actually going to write those in factored form. So I'm going to have the x plus 2 over the x minus 4 equals 30. And I'm going to write this guy factored. X minus 4, x plus 1. And then plus 4 over x plus 1. All right, so I'm going to write it factored because I'm about to start canceling things. And then I am going to multiply every single one of those terms by this common denominator. So I'm going to multiply the x plus 2 times this common denominator. All right, I'm going to multiply the 30 by this common denominator. And I'm going to multiply the 4 by this common denominator. Everything's getting multiplied by the common denominator, all right? And then you can see that all my denominators should cancel, all right? So I am going to cancel. X minus 4 will cancel out of that denominator, and I'm left with the x plus 1 times the x plus 2. Here, the x minus 4 and the x plus 1 cancel. I'm left with just 30. And then over here, the x plus 1 cancels. I'm left with the 4x minus 4. So this process will always get rid of all of your denominators. If it doesn't, you did not find the right common denominator. All right? So once I've done that, I am going to just solve, as I always would. On the left-hand side here, I'm going to distribute. So I'm going to say x squared plus 2x plus 1x plus 2, 30, and I'm going to distribute here, 4x minus 16. All right. And then I'm going to combine like terms and move everything to one side. So this is going to be 3x. All right, and then I'm going to start moving things over. So I have x squared plus 3x plus 2. I have 4x. And we're going to go ahead and combine these. All right, and then I'm going to move everything to one side. Anytime you have an x squared, you want everything to one side set equal to 0 because we're going to factor and solve it, okay? So I'm going to move my 4x over, and I'm going to move my 14 over. All right, on the right-hand side, I should have 0. That's my goal here. 0. Over here, my x squared did not combine with anything. 3 minus 4 gave me negative 1x. 2 minus 14 gave me negative 12. All right? So far, so good. How do I solve something like this? It's a quadratic. Yeah, I'm going to factor it and set each factor equal to 0. This is pretty easy factoring. What is my factoring here? So I have x minus 4, x plus 3 equals 0. Set each factor equal to 0. What are my two possibilities here? X equals positive 4, negative 3. I need to check them. What happens if I plug in a positive 4 here? 0. If I plug in a positive 4 here, I get a 0. Anywhere in the denominator that gives me a 0 is a problem. It doesn't have to do it for all of them. So this is not going to work. All right? Negative 3. Negative 3 here gives me negative 7, negative 7, negative 2, negative 2. That's quite all right. It doesn't matter if it's a negative. Then the 4, however, is extraneous. So my only answer here is negative 3. Find two positive numbers whose difference is 6 and the sum of their reciprocals is 1/4. So the first thing you're going to do here is you're going to see what you don't know and set variables for them. So I have two numbers. I don't know either one of them. So I'm going to just name the first number is just going to be x. Difference is 6. So if I were to then add 6 to this guy, then when I subtract them, the difference would be 6, right? They should be 6 apart. That's what the difference between them means. Difference does mean subtraction, right? But if you were to subtract my first number and my second number, you would end up with 6. X plus 6 minus x is 6, right? So it's just telling me they are 6 digits apart, is how far apart they are. They're 6 numbers apart. So if my first one is x, my second one should be x plus 6. Because when I subtract those, I should get a difference of 6, right? And so that's the first thing I'm going to do is just establish what those two numbers are. X and x plus 6. Sum of their reciprocals. Well, now I need the reciprocals. Well, the reciprocals of these are just going to be 1 over. So the reciprocal of this one is 1 over x. The reciprocal of that one is 1 over x plus 6. Right? Then it uses the term sum. Sum of the reciprocals. How do I write that algebraically? So 1 over x plus 1 over x plus 6 is 1/4 equals 1/4. All right? Then I have an equation that I just learned how to solve. How do I solve this? My first step is to do what? Find what? Find my common denominator, right? And so these are about as factors as you can get. X, I'm going to have to use. I'm going to have to use x plus 6. And I'm going to have to use a 4. So I would write that a little more simply. I would say 4x, x plus 6. That is my common denominator. And then I'm going to take each one of these and multiply by 4x, x plus 6. So 4x, x plus 6 here, 4x, x plus 6 here, and 4x, x plus 6 here. And then I'm going to cancel. All of my denominators should cancel if I did this correctly. X and x. So I have 4 times x plus 6 times 1. Over here, my x plus 6's cancel. I have just the 4x times 1. And over here, my 4's will cancel, and I have x plus 6. Everybody see what I did? If you do it right, all of your denominators should cancel. All right, so now I'm just doing a basic equation to solve. All right, I'm going to distribute. Distribute here. And then I'm going to move everything to one side and factor. I always move things to where my x squared is positive, by the way. So since my x squared is on the right, I'm going to move everything to the right. This is actually 8x, right? So if I subtract here, if I were to combine those, right, I would get 8x plus 24. So I'm actually going to subtract an 8x. And I am going to subtract a 24. And so I end up with x squared minus 2x minus 24 equals 0. That's pretty easy factoring. What are factors of negative 24 that add up to give me negative 2? Yeah, so I'm going to say x minus 6, x plus 4 equals 0. X can either equal 6 or negative 4. All right, 6 or negative 4. I need to go back and make sure that this actually works, all right? Because I have a question that kind of narrowed it down for me. What's my first few words of my question?
2 positive numbers.
2 positive numbers. So which one of those clearly is not going to be part of this?
-4.
Negative 4 is automatically not going to work. It wants 2 positive numbers. So I need to go back up here and say, well, if 6 is my first number, 6 plus 6 should be my second number, which is 12. So my 2 positive numbers are 6 and 12. All right. It doesn't mean that negative 4 would naturally not work here. But my question specifically said 2 positive numbers. A large pool can be filled in 8 hours of continuous pumping using only pump A. All right? If a smaller pump B works with pump A, it only takes 6 hours to fill the pool. How long would it take to fill the pool using only pump B? All right, so we're going to start with a chart type problem. We're going to say we have this pump A. The time that it takes to fill it is 8 hours. So the rate here is just a unit rate. Per hour, it fills 1/8 of the pool. That makes sense, right? If it takes 8 hours to fill the whole thing, then your hourly rate is 1/8, right? Pump B, we actually don't know how much time it takes by itself. We do know its hourly rate would be 1/T, whatever that time is. We also know what happens when we do it together. Together, the pumps do it in 6 hours, so their together rate is 1/6, which means their hourly rate should also add up, by the way, right? Their hourly rate should add up. So we can actually just add that column and solve for our variable. All right, so while it looks crazy, it's really not that bad of a problem. 1/8 plus 1/T equals 1/6. All right, that's a T. I just am talking and writing. All right, so I am going to look for my common denominator. What's your common denominator between 8 and 6?
2.
No, common denominator is not going to be your least common factor. You want your least common multiple. So go multiples of 8. So 8 doesn't work, 16 doesn't work, 24, right? So between 8 and 6, your common multiple is 24. And then you also have a T in the denominator, okay? So once again, I'm going to find my common denominator here. My common denominator is still the first thing I'm going to find. And then I'm going to multiply everything by that common denominator. All right. Things will cancel. 8 cancels with 24. I'm left with a 3. So I have 3T. It'll write for me. T will cancel, and I have just the 24. And then 6 and 24 cancel, and I'm left with just a 4T. Okay? Easy enough. How do I solve it? Yeah, move all your variables to one side. And they were nice. 24 equals T. What does that tell me? Pump B takes how long to fill it by itself? Yeah, it takes 24 hours. 24 hours to fill it by itself.